In our lesson 41 today, you're going to get to learn about the rest of those trig buttons. The things that say SEC, which is not set or second, and COT, which is not hot, and CSC. So we're going to define those and what they stand for and work with those. We are also going to talk about another way, a special notation that is sometimes used when we're talking about the permutations, when we arrange a certain number of things on the order matters on it, and how we can enter that on the calculator. So beginning with our reciprocal trig functions, let's first review a little bit of vocabulary. If we say opposite, we are talking about one's positive and one's negative, and that's the only change that we're making as we go from one to the other. Reciprocals, we are talking about switching the numerator and the denominator. So maybe if we have A over B, we go to B over A. Those are reciprocals of each other. Sometimes we also say that if we have one number, the reciprocal is 1 over that number, and that's especially what we use, especially the way we used it when we were graphing reciprocal functions. Inverses undo the other. They change, if you start with X, do something, what will get you back to the X that you started with. And we've been doing that, and we're taking the compositions both ways to see if it works out. So just if we wanted to do a quick example to review each of these, if I wanted to take the opposite, I just put a minus sign in front of that. If I had the sine function and I wanted the opposite of that, I just put a minus sign in front of it. If it was negative, it's now positive. If it was positive, it's now negative. What we will be talking about today will be the reciprocal trig functions. So if it was a reciprocal function for y equals x squared, we might say that the reciprocal there is 1 over x squared. We would say that the reciprocal for the sine function would be 1 over the sine function. And we'll give that a special name in just a moment, one of those other trig buttons. If we wanted to talk about inverses, for y equals x squared, we change that to x equals y squared, and then we would solve that for the new y, so we would have y is the plus or minus square root of x, not a function in that notation, but that would be the inverse. And we've been talking about inverse trig functions, that if I wanted to take the inverse of this, I would be talking about theta would need to be the inverse sine of y. What angle has y as its sine? Or we've also been using the term arc sine of y. So this is the one that's going to be new that we're going to talk about today. 1 over the trig functions that we have already learned. So, they are going to have the names secant, when you see SEC, cosecant, and cotangent. Their definitions are: secant is the reciprocal of the cosine. Cosine is the reciprocal of the secant. Cosecant and sine are reciprocals. Cotangent and tangent are reciprocals. Couple of things that we want to think about with that. If we were doing right triangle trig, we know that cosine is adjacent over hypotenuse, so secant would have to be hypotenuse over adjacent if we were doing this on a right triangle. If sine is opposite over hypotenuse, the reciprocal on a right triangle would have to be hypotenuse over opposite. If tangent is opposite over adjacent, the reciprocal cotangent would have to be adjacent over opposite. we do need to be a little bit careful. Undefined if the denominator is 0. So since, for example, cosine is 0 at the top and bottom of the unit circle, so at the top and bottom of the unit circle, that means that secant is going to be undefined because we would get 1 over 0. Does that make sense to everybody? Now, special case with tangent, because tangent we already had some places where it was undefined. And so if I take 1 over undefined, what does that mean? I know 1 over 0 is undefined, but what is 1 over undefined? So in that case, we would think about the other definition for cotangent. We've seen that tangent is sine over cosine. So if cotangent is the reciprocal, it is also turn the tangent upside down, turn sine over cosine upside down, and you have cosine over sine. So that means if we are at the top of the unit circle where the tangent is undefined, we would think about that as cosine over sine, which would be 0 over 1, which makes perfect sense. I think I've got this on the next slide, just so there's not quite as much writing of what we're going to do with that. So, you already have this down, you don't need to write this down again, but we are just saying cosine and secant are reciprocals of each other. Similarly for the other two pairs as well. Secant is 1 over cosine, cosine is 1 over secant. We can go either way with that, and we'll need all of these when we start doing trig identities before too many more lessons go back. And then what I was just saying, if tangent is undefined, so cotangent is 1 over undefined, it's going to be 0. If tangent is 0, cotangent is undefined. And those go both ways. Okay, for our first example, first thing we want to do, and do not shortcut, do not try to do this mental math. I want you to actually write down, oh, this is a reciprocal one, so it's 1 over some different trig function. Don't try to figure out what it is and flip it all at once before you write it down. Trust me, I see mistake after mistake, year after year after year, because students try to shortcut. It's not that hard to write this extra step down. Secant, was that 1 over cosine, 1 over sine, or 1 over tangent? You can tell me which one on secant. Okay? And so we are going to write it down like that. It is not 1 over the cosine of 390 degrees. The 390 has to be right there with the cosine. So just in terms of notation and how you write that. And then we are going to have 1 over the tangent of negative 420 degrees. Then we are going to figure out where we are on the unit circle and write that in. So for the first one, I'm going in the positive direction. And let's see, how far do I need to go? All the way around is 360, that's not far enough. I need to keep going. So I'm at that lowest one that's completely in the first quadrant. Cosine, that's my x. So here's my y-axis, I'm on the right. Cosine positive or negative over there? It's positive. How many at that spot? Root 3 over 2. So I put the root 3 over 2 in the denominator because that's the cosine. It's 1 over that. Questions on to that point? Then I'm going to go to the other one, and I'm going to write down 1 over, and then I'm going to figure out what the tangent is. This time I need to go in the negative direction. So I go, let's see, 360 gets me all the way around 1, so it's not far enough. I need to go 60 more. So now I'm down here, pretty far into the fourth quadrant. Tangent, positive or negative in that quadrant? Negative. So I'm going to have a negative number there, and do you remember negative how much at that point? 30. Negative root 3. Try to remember to raise hands though. Okay, then let's see if we can simplify this. 1 over means we take the reciprocal, so now we're going to flip this one, so it's 2 over root 3. Plus a negative, I have minus 1 over root 3. I know the root 3s don't really belong in the denominator. I'll make sure for the final answer I clean it up. But those are like terms. The root 3's in the same place on them. So 2 of them minus 1 of them gives us 1 over root 3. And then, yes, I'll clean it up so that I have positive root 3 over 3. Anybody with a question on that one? Oh.
Why didn't you just take the denominator out and do the reciprocal of just the denominator?
Because 1 over root 3 over 2 means the reciprocal of the denominator. If you think back to dividing by fractions, 1 divided by root 3 over 2 is 1 times, flip the second one. So just it's still consistent with what we've been doing, but 1 over means the reciprocal. Okay, next example then, this time with radians. This time I have root 2 over 2 times something. Cosecant is one of the reciprocal functions, so it is 1 over, and cosecant is 1 over what? 1 over the sine. And the angle stays the same, the minus 5 pi over 4. And I'll figure out what that needs to be in a few minutes. And then I'm going to have minus square root of 3 times something. Secant, that's another reciprocal one. Secant is 1 over what? Everybody? 1 over the cosine, and the angle stays the same. That means I have root 2 over 2 times 1 over, and I need to figure out what goes in there. So, negative direction, I start out going down. So I get 5 pi over 4. So let's say halfway around is pi, that's 4 pi over 4, and I need 1 more fourth, so I am right smack in the middle of the second quadrant. Is sine positive or negative there? It's the y. It's positive. Positive how much? Okay, ladies and gentlemen, our choices in any quadrant are 0, a half, root 2 over 2, root 3 over 2, and 1, or the negatives of those. But it will be root 2 over 2. But 1 is smaller than the root 2, is smaller than the root 3, so if you're close to the 1 or the negative 1, it's root 3. If you're right smack in the middle, it's the root 2 one. If you're closer to the 0, it's the half one, or the negative. That one's right smack in the middle, so as you were just saying, it is root 2 over 2 for this denominator, 1 over the sine. That means that that piece becomes root 2 over 2 times 2 over root 2, or that piece of the complement becomes a positive 1. Then we still need to do the second part of it. So for this one, I have minus root 3, I'll be in the numerator if that matters, and then I need 1 over whatever the cosine of 11 pi over 6 needs to be. So this time I need to go in the positive direction. Not quite 2 pi. Halfway around will be pi, 6 pi over 6. Twice around would be 12 pi over 6. This is one spot less than that, so it's the highest one that's down in the fourth quadrant. Cosine, that's the x. It's a positive or negative on that side of the y-axis. So 1 over a positive something. The x coordinate, is it the one that's pretty close to 1 or it's pretty close to 0? So what's the number? Root 3 over 2. So what I have is minus that root 3 on the outside. Flip this one, 2 over root 3. My root 3's cancel. 1 minus 2 gives me negative 1. Okay, see what we're doing with the reciprocal trig functions. Just one step beyond what we've been doing. Okay, last thing for today is some calculator work. The number of permutations of n things taken all at a time can be written with that p. The total number goes up here on the left, and how many we're taking at a time goes here. It is n factorial, the total number of things we're choosing from, not over r factorial. You've got to subtract those two to get the denominator's factorial. So let me give you an example of what that might look like. If I had the permutations of 17 things taken 6 at a time, I am used to 1, 2, 3, 4, 5, 6 things, right? I have 17 choices for the first, then 16, 15, 14, and I should stop at 12. That's what I'm used to. This formula says take 17 factorial over, subtract them, 17 minus 6 is 11. So if I wrote out the whole factorial, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, I'm just going to write as 11 factorial. Over 11 factorial, those would all cancel, and I have what I'm used to seeing with this notation. Does that make sense to everybody? Okay, now let's do one example on this. I require that you give me one or the other of the ways of writing a factorial. I want to, in your paper, you can write that. You can punch it in like that on the calculator, but you still have to write on the calculator 5 factorial over either. You can write the 5 minus 2 factorial, or you can just subtract and write the 3 factorial. But I want to see that you know what it means with factorials. Then we're going to enter it on the calculator, and you have 2 choices for how you could enter that on the calculator. You could do the control divided by and get your fraction template. You can put the 5 in the numerator, go to the button right under the enter, and choose the exclamation mark. Go to the denominator, put in either parentheses 5 minus 2, or just put in 3 with the exclamation mark again, and get that the answer is 20. Or you could have the calculator do that P notation. You could do this front button is menu. The calculator's got to have some way of doing permutations. I just have to see if I can find it. I think we usually talk about permutations when we're doing probability. Yep, there it is. Select permutations, and it has that notation. So then I need to tell it the 5 and the 2, so I do 5. The bottom left button right under pi is your comma, and then the 2, and then enter, and you also get 20. So you may want this easy, you could either do by hand, or you could enter it either way on the calculator, but I need to see something written with the factorials before you write your final answer if that is 20. So now you guys, one way or another, do that one I was just talking about, and this will wrap up our lesson for today. Permutations of 17 things, taken 6 at a time, write it down with factorials, punch it in one way or the other on your calculator. I am not really going to punch in on my calculator 17 times 16 times 15 and so on, and I'm not going to try to do it by hand. I would simply do it with the calculator. Amy, what did you get?
8,910,704.
And remember, commas are required. Start on the right, 1, 2, 3, and you've got a comma, 1, 2, 3, and a comma. Not okay if you just wrote what I have up here on the board. No matter how you enter it on the calculator, I need to see 17 factorial over 11 factorial or over parentheses 17 minus 6 factorial. Anybody with a question? Then that wraps up our lesson for today.